Gentlemen, welcome back to the shop. Needle Bender 785, Cleveland, Ohio, with a kind of a interesting video, which I thought would be pretty cool, talking about a lot of people nowadays are buying amplifiers, getting into tubes, and just talking to people in radio world. Business is booming, and people either getting back in the radio or getting on the radio, or starting out in the radio for the first time with their new box and stuff like that. And I kind of thought I'd share an interesting topic regarding cooling of various tubes, and that this does not really have to do with any one particular tube, but kind of any tube that you can get a data sheet for, and it tells you what the cooling rate, because there's a lot of misconception out there between static pressure, CFM, water column, and there's a lot of people that kind of beating around the bush and not fully understanding that. And I've actually got to talk to a real RF engineer. It has nothing to do with CB amplifiers or ham amplifiers, but somebody that worked in the medical field and worked with different tubes for medical equipment, and the way they cool their tubes and check for proper cooling. And I've actually taken his advice and kind of bought the equipment and decided to see what I was doing. And turned out my blower that I had in my personal box wasn't quite adequate. So I actually wound up upgrading my blower to a more high performance blower, and then being able to measure that using this piece of equipment, which we're going to get to here in a little bit. And also went a step further and introduced this piece of equipment here, which is a static pressure switch, which is awesome. Found this one on eBay. They're usually like 60 bucks. I managed to pay 45 for. Very simple to operate. There's one set of contactors, normally open and normally closed. And however you want to wire it, something closes or something opens. You can see the contactors. The one on the right is the common, and the one on the middle, just like a relay. I mean, it's what it is. It's a pressure relay. It's a passive component. There's no power required to it. Mounts, and it samples the air right here on this copper pipe versus this little, so it's a differential. So it samples the air in this little thing right here. So anyway, I wanted to see if I was adequately cooling my tube, and also, like I said, I went in a step further and installed one of these devices in my box. That way, if this blower gets clogged up, blows a bearing, gets a sock sucked into here, something stupid happens where it will shut down my filament, it will shut down my high voltage all at once. And it will not let me turn on those things until proper pressure is established underneath there. And so kind of getting back to my conversation with this RF dude that I talked to. And if you look at a data sheet, for example, we're going to be talking about 3CX3000. You pull up the temperature data sheet for sea level. There's sea level and there's 10,000 feet, and you can interpolate however you want it. Like I said, those values are for continuous duty dissipation. Doesn't mean the tube is putting out that much power, the anode dissipating. You have two numbers, whichever column you decide to use, and we're not going to get into exactly what we need for what we're doing here. We're just going to learn how to interpret this chart. There's two values. There's a CFM and there's a static pressure. And both numbers kind of, they're interconnected. So if one goes up, the other one goes up, basically. So the way we measure, and the way the professionals actually measure the tube, if it's getting enough cooling, is not by CFM, because it's kind of impossible to do. You can have a fan rated for the proper CFM, but not putting up enough static pressure. I've come across some amps where people will buy a 500 to 700 CFM blower from Dayton, and if you look on their chart, their maximum static pressure is like 0.64 inches of water, because we measure our static pressure in inches of water column, and we have a meter that's going to be doing this for us here. we're going to do a little demonstration. And this pressure switch actually measures pressure in water column. And if you look at our data sheet, we have water column and we have CFM. So the way I've learned to do this, and I'm not saying, you know, this is the way everybody should be doing this, but the way I found to do this is if we are getting adequate pressure, if there's high pressure in here that meets the data sheet specifications, that means we are getting adequate airflow through the tube. The CFM, where the CFM rating comes into play, is to make sure that the blower can provide enough CFM at that static pressure. But the static pressure is kind of a key number to know that we are getting adequate airflow through the tube. If we got, for example, to have maximum, absolute maximum power capability out of a 3CX3000, we need to have 1.4 inches of water column, and that will equate to 127 CFM going through the tube. Now that's actually really, if you really look through the blower data sheets, it's really hard to find a blower that does over one inch water column. You can get a big blower that does 500-600 CFM and you're like, oh man, this is great. I'm gonna cool my tube with 600 CFM. Well, it doesn't work like that. If the blower will reach its maximum back pressure, it will actually not suck any air in, and you'll get really little, if any, airflow to actually go through the tube. And the way, like I said, you measure it is by measuring static pressure, which we have this little hose connected over here, and we're going to be actually measuring static pressure here in a little bit. So talking to this gentleman there, kind of getting knowledge from people that are not in this hobby, that have just been using these tubes for various other applications which were they're actually originally designed for. These tubes run like 24/7 in MRIs, radio tower transmitters for different radio stations, and talking to somebody that worked with them and getting his input on how they're cooling these tubes and how they're measuring adequacy of the cooling of the tube, I've decided to implement this little demonstration I'm going to do. So first thing we're going to do is we're going to turn on this static pressure meter, and we're going to make sure it's going to be reading zeros and what it's doing. So we are in inches of WG, that's water column, and let's just kind of go through the scale here. We have millibars, we have pascals, we have PSI, which is so inches in water column. Let's get back to that. There we go. So now we got zero. We zeroed it out. We don't normally we need to, but I just zeroed it out. So also, I'm going to do a little demonstration. I'm going to measure between the contactors. I apologize, my hand is in the way, but we have this little continuity meter, and I'm going to measure okay, so we can see that we got an open circuit. So as it is right now, if we would plug the SAMP in and turn it on, the power supply would not allow any heating of the filament or the high voltage circuit to power up. And that's the new safety system I put in. So just for demonstration, we are only powering the blowers on this. As you can tell, the high voltage is nowhere near. It's actually on the other side of the room. There's no filament. It's just basically the blower. So we're going to turn this on. So as you can see, we have 0.96 fluctuating 0.95, almost 1 inch, I know, close to 1 inch of water column pressure. And you can see that it fluctuates. As I'm going to put my hand near it, and let's say I'm impeding this airflow, you can see a drop. So now we know that it's working. So now we're going to measure this little pressure switch that's protecting our tube and see if it has indeed turned on. Yep, so now we know we can operate this tube. I thought it would be a really cool video just to do a little demonstration of this thing actually working, and for people that are interested how to properly cool your tube and make sure it is cooling. Anyway, if you have any questions, feel free to drop a line, contact me on my email address, or just via YouTube. I'll be try to answer any questions and stuff like that. But for now, that's all I got. Thought it'd be a little cool video. Anyway, 73s, this is Needle Bender 785, Cleveland, Ohio.